Students. Today we are going to see about activity diagrams in UML. This activity diagram comes as a part of UML dynamic behavioral modeling, since it involves multiple number of activities which needs to be told about any kind of application when it works, when it gets executed, and when it is going to show some kind of behavior to the user in terms of transformation of a particular system from one level to another level. So this activity diagram, to be precise, it is exactly like the Raphia flow chart, but still much more in an explanatory form, as well as more number of notations, which are nothing but we call them as symbols which are added on to that. So let us go without wasting much of the time. We'll go in depth in terms of understanding what this activity diagram is all about and how it is going to be useful in terms of a person who is going to learn about a new system. How he is going to get a kind of clarity in terms of the ways how does the activities are going to be done onto that particular application. So to start up with, as you can see, activity diagrams, they represent the dynamics of the system. As I already told you, like if you take any kind of system, it involves a kind of execution which has to happen. This execution is nothing but we call it as a functional executions, because during these executions the system will behave in completely a different manner. The way how it was, the reason how it was developed, or the form how it was created, it's going to be completely changed. And this particular change is the one which is responsible for making the system to demonstrate some kind of dynamic behavior. So they are used to represent, the activity diagrams are used to represent this dynamic behavior. And when I look out into the kind of a form or the resemblance that the activity diagram is going to have, because anything, if at all we are going to learn in something which is new, it's better to learn along with the things which we know already. So flowchart is a kind of thing which we know already. We have already been used to the flowchart, because any kind of person who are into computers and is going to start his career, when he wants to go for developing any kind of program, the first and foremost thing what he was given with the kind of training by the teachers will be to construct a flowchart. So you'll be constructing a flowchart, then you'll be constructing an algorithm, or algorithm, then we'll go for a flowchart. But this flowchart, it is mainly used to show the kind of flow of the activities that happens in a given system. The same kind of thing only this particular activity diagram is going to show to us. So as we can see, the kind of additional set of things what are all visible in terms of the flowchart is, we can see the kind of activities that are going to happen on the system from time to time. So if you are going to take a particular system, it is not uh, a kind of magic that happens like at one single process the entire system is going to get converted from one form to another form. That is highly impossible. It's a kind of multiple number of processes which has to happen parallelly, or it has to happen sequentially according to the way how the system is formed, or the kind of logic is given onto the system. The same thing only is being captured in terms of a diagrammatic form by means of a flowchart. So we can understand like what sort of activity is going to happen in a sequence, or what sort of activities that are going to happen in a particular process in terms of parallelness. So that is what the flowchart is going to reveal to us. And along with that, another important thing to note on over here is the kind of path or the control path what the system is going to choose, depending upon the conditions, depending upon the realistic situations in which the system was implemented, the system will definitely undergo, as the system will definitely go for choosing its own path. So when we are going for understanding the system, it is very important to know the kind of alternatives that are going to happen in the particular system's level path. So as I told you, like it may happen sequentially, it may happen parallelly, but there is a kind of contradictory factor onto that, like things may go without going into a sequential means. It may divert, it may switch from one form to another form in a different path flow. So that is being captured in terms of a flowchart. So the flowchart can show the flow across use cases or within a use case. So here we term the use case and nothing but the processes. So flowcharts are used to show us a kind of use cases or nothing, the processes the flow of processes. So when it comes to the activity diagram, as I already told you, it's a kind of another form of representation of a flow chart. Here, for an activity diagram, the core symbol is an activity. Okay, so this is a use case. This is a process. What we mean to say, and the activity diagram is completely going to show us the functionality, or the completely going to show us the processes by means of this particular symbol, which is represented over here, and it shows some set of tasks which needs to be done, sounding similar to flowchart, right? So that is what activity diagram also does. And each activity can be followed by another activity, which we call it as a sequencing. And there are some triggers for the activity that may be guarded as in state diagram. So state diagram has got some kind of, we might have studied during the state, while we are learning about the state diagram, that the triggers are the ones which are responsible for transforming the system from one level to another level by means of the activities. So those triggers are also, we can go for understanding them, we can go for learning about them, we can go for getting to know about them in terms of the use case, in terms of this particular activity diagram. So when you come into the symbol, so it's pretty simple, like that of a flowchart. Here we have a diamond, which we call it as a symbol which is used for taking some decisions. As you can see, like the diamond has got, here this diamond has got 4 different edges. So these edges are used for a control flow to flow into the system. And we are going to put some condition over here, and we are going to take the condition. Based upon the condition, we are just going to transfer the path by means of 2 different edges. That is, one through the yes and another through the no. And if in case it is required, based upon the execution of this particular alternative paths, if it is really required, we can just come back and go for reiterating whatever the set of processes that we have done earlier. So for those particular purposes, all these 4 set of edges are given. So one edge is for a condition to flow in, another 2 edges are meant for, depending upon the outcome of the condition, either it's going to be yes or a no kind of Boolean output to capture that and to execute the set of flow what the system has to take according to this particular outcome. And another one more condition is meant for iteration. Okay, so here each trigger comes out from it as a guard. Okay, guard is the sense like it is a kind of factor which ensures that that set of events are going to completely be undertaken. So that is a guard factor over here. And we have another set of symbol called a synchronization bar, which can be represented by means of an horizontal means or a vertical means. The need for having horizontal vertical means are completely dependent upon how does the diagram is going to get constructed, and how does the paths are going to end up with. If it is a kind of a path which is going to flow from top to bottom, we can use a different set of paths that are going to flow from top to bottom. We can use horizontal synchronization bar, or if it is going to happen from the left hand side in terms of multiple paths, we can go for using the vertical synchronization bar. For that particular purpose, this synchronization bars are used. And this set of synchronization bar, to be precise, they are not available in terms of a flowchart. So you cannot go for finding in terms of flowchart, but little bit of enhancements are happened onto the activity diagrams in order to have this synchronization bar also. And here, when you look out into all the triggers from these activities attached to activities that can occur in parallel with no specific sequence or concurrently. Okay, so this particular synchronization bar are used for combining some set of processes, or to go for showing this collection of set of processes. Okay, so while you're going for, as we already told, like many number of tasks are going to get is going to happen, and they are all going to come together in order to make this activity to undergo. So when this activity is going to undergo, this set of processes are needed to be shown as a complete collection. For that particular purpose, we are just going to use this set of collection bars, which otherwise called a synchronization bar. So the name synchronization itself tells that few number of activities are synchronized together in order to make a particular activity to happen or occur over there. So when we are going to look out into the synchronization bar, we are going to have some set of synchronization bar. The first set of synchronization bars are going to open up a few set of activities which are going to come together, and we are going to have another synchronization bar which closes the concurrency. So when I'm going to have 2 synchronization bar, the first one is meant for showing many different number of branches, and when you're going to have the closed iteration involved, it is going to close the entire set of concurrencies. And here, in terms of this decision activity, we are going to have this asterisk symbol also, the support of asterisk symbol, in order to show us the kind of iteration that may happen in a particular event. So as such, when you're looking out into a flow chart, we may need to go for using this particular symbol in order to show the iteration. So here, since in UML, we are not going to go to that level of depth for a programming codes level of constructing a flowchart, we are just going to use an efficient use of this kind of small notations, which may go for replacing this iteration representation in a decision diagram. So for that particular purpose, we are going to give a hashtag symbol. So presence of a hashtag symbol itself is going to make us clear that this particular setup process is going to happen iteratively without having any kind of conditional expressions to stop or break that iteration. It keeps on happening again and again and again. For that particular purpose, we are just going to use the hashtag symbol. And here, the activity diagrams, we can go for describing the use cases or complicated methods. So when you're looking out into the actual purpose of an activity diagram is, it can be used for showing the use cases. What are all the processes involved in a particular activity to occur, and what is the kind of transformation that are going to happen to that particular activity as a result of this particular process execution. For that particular purpose, we are going to go for using use cases, or we can go for a process of explaining the complicated method. So what we call it as a complicated method means any kind of method wherein we require to act as a substitute for a complex procedural development, complex software development. If you look out into any kind of software, it's not like a complexity is going to be widespread all over the system. At one particular point, or at few particular areas, the complications may be more. So those areas and all, if you look out into a role of a flowchart or role of any kind of structural diagrams, their role is not up to the level of expectation compared to that of the kind of support what UML is going to provide. Of course, used for object-oriented software development. So here, using the activity diagram, we can go for showing how does the set of activities that has happened in terms of a complicated complicated part of the system. For that particular purpose, we are going for using the activity diagram. So coming into an example, so we so far learned about what are all the functionalities of activity diagram, what they are actually meant for, and what are the new additions of notations in terms of activity diagram compared to that of a flowchart. And in this particular example, now we are just going to deep dive into the examples where we are going to have a glimpse of how does an activity diagram will look like. So this is a simple process of a vending machine. Okay, so it's a beverage vending machine or a coffee vending machine. And for our simplicity purpose, we are just going to consider that it is one single machine which is used for the purpose of finding a beverage, which might be a coffee or which might be a Coke. So initially, what we are going to do is we are going to find a beverage. That is a kind of use case, or that is a kind of process that we are going to do at the inception. And if the beverage is found, we can just go for what is the kind of beverage that is being found. Okay, whether it is a coffee or if it is any kind of soft drinks. What is the kind of beverage that is available in that particular vending machine? That is what we are going to find it first. Based upon that, we are going to take a decision. So if it is a kind of beverage which is not of a coffee kind, we're just going for we are going to the path of getting a Coke. Okay, so that does not require any kind of preparations or any kind of process involved into that, process in terms of manufacturing involved into that. So of course, we might have we should have inserted the coin for that particular beverage to come out of it. And once we are inserting a coin, we are just going to find what is the kind of beverage that is available in the particular machine based upon the light which gets littered over that particular dashboard. So if the dashboard is going to lit a light of Coke, we can just go for getting a Coke. So get a can of cola and we are just going to stop the process. So this is used for stopping the activity diagram. Symbol used to represent or a notation used to represent stop for an activity diagram. But when it comes to the process, like there is no coffee found. That is, coffee is found over here. Okay, this is in the case of no coffee. This is the case of coffee is found over here. Of course, that is given with the higher order priority because the customer wants coffee. Okay, customer requires literally he wants a coffee, but the coffee is not found means he's going for taking the option of a Coke. But if the coffee is found means he's just going to involve into three different parallel activities. One is something like put coffee in filter, another is add water to reservoir, and third one is get the cups. As we all know that it's a kind of simple process. Those who are involved in preparing a filter coffee, you might have got used to this particular process, and easily you can understand what is the actual parallel process involved into that activity. So here, first activity is put the filter coffee in filter, and we're just going for putting the filter in machine, and we are just going to wait for a while till that adding the water to the reservoir is going to happen, and that two set of activities are going to come, are going to go down to the deep in terms of synchronization. So they have been synchronized, and as they are going to synchronize, we are going to turn on the coffee filtering machine, and as we go for turning on the machine, it automatically brews. The coffee is going to brew out of it. Once the coffee is going to brew out of it, we are just going to pour the coffee, and we are going to drink the beverage. Instead, we are going to not only just going to be involved in the process of brewing the coffee, we are going to wait for a while for the cups also to be attained. So we need not to wait for a while. All the three processes can happen parallelly, but whatever the kind of activity that we have done, have to wait for this much number of processes to happen over here. Obviously, coffee have to be prepared. It is not a ready-made coffee. For that particular purpose, we are just going for getting the cups, and we are after once we got the cups, we are just going to go for pouring the coffee and drink the beverage. So this is a simple process of explaining you how does a simple activity diagram will look like. So out of this particular activity, a user who doesn't know how to go for preparing a filter coffee will get an idea of, okay, this is the actual process involved in terms of it. And he also understands that few number of activities can happen parallelly. We need not wait for one activity to complete in order to do the another activity. Of course, we need to wait for putting that activity what we have done into practice, because pouring the coffee or brewing the coffee is ultimate thing over here. So brewing the coffee can happen only when we are going to put the coffee into the filter, and when we are going to add water to the reservoir. After that only this process can happen. And drinking the coffee can happen only when, pouring the coffee can happen only when we are going for getting the cups. Then only it can happen. So after the process is done, we will need to go for wait for a while, but we can do all the three set of processes parallelly. Okay, so that is what we understood by means of this particular diagram in terms of vending machine. So another set of example we can go for learning about in terms of order processing. Okay, it's a kind of case study. What was stated in front of us in order to learn it as easy as possible. When we receive an order, we check each line item on the order to see if we have the goods in stock. So line item in the sense like what are all the items that have been ordered by the customer. That is what we call as a line item. If we do assign the goods to the other, if this assignment sends the quantity of those goods in stock below the reorder level, we reorder the goods. So it's a kind of inventory activity wherein the products are available in the godown, and we are just going to gather the products, and we are going for delivering the products based upon the orders that has been made by the customer. So in order to do that, we need to go ensure that the orders are available. Okay, they have been available in the inventory, available in the godown, and we are just to keep on moving the products from the godown, and we need to go for keeping a minimum level of products to be remaining. And as it crosses the minimum level, we need to go for reordering the goods. While we are doing this, we check to see if the payment is okay. So very importantly, as soon as the order is made, it doesn't mean that we are just going to deliver the product. We are going to ensure that the payment is also going to happen from the end of the customer. If the payment is okay and we have the goods in stock, we dispatch the order. Of course, this is the kind of a prototype what has to be followed while we are going for sending goods to the customer based upon their requirement of the order. If the payment is okay, but we don't have the goods, we leave the order waiting. If the payment is not okay, we cancel the order. So here, if the payment based upon the payment, and we have the, if we are not going to have the goods, we can leave the order in the waiting stage. Okay, so this is one particular scenario what every set of people who are going for ordering the product will undergo. So we are literally going for waiting for the goods to arrive to our premises or to our godown, and based upon that, we are just going for delivering the product. If the payment is not okay, means we cancel the order, because the person cannot go for making the order without doing the payment. Obviously, he has to go for doing the payment. So maybe like the payment is done, but it is not a successful payment, we can go for literally canceling the order. Okay, so for that thing, we just going to create a activity diagram, and one more process is involved in terms of receiving the supply. So we are thinking only from our stock level, only from our factory level, but goods to our factories have to come from somebody else. So that is what receiving the supply. So when we are going for receiving a supply, we have to ensure that the surplus amount of quantities was received according to the way how we can just going for how we can go for satisfy the customers or requirements of the customer. Say, for example, some products may have a high demand at one particular point. So during that particular time, we should have enough number of products with us in order to ensure that the product can be delivered to the people without any kind of delay within it. Okay, so more delay means obviously the customer will be an unhappy customer, and as a result of it, they won't come to your website or application no more further. Okay, so in order to avoid that, we need to go for having a module check on to the receiving the supply process also. So let us go quickly into that. When a supply delivery comes in, we look at the outstanding orders and decide which ones we can fill from this incoming supply. We then assign each of these to its appropriate orders. Doing this may release those orders for dispatching. We put the remaining goods into the stock. So already demand is existing, and we need to go for doing the supply of the materials. So we are going to ensure that the product is available. If it is not available, we need to go for reordering the product, and the product has to come as a supply from the place where it got manufactured. So already order is there in line, and we need to go for satisfying those orders by sending the products. Okay, so after sending all the products, after sending all the requirements of the customers, all the items have been dispatched, means the remaining items we can put it in the stock, which can be used for the lateral supply, which is going to happen in the future days. Okay, so for that only we are just going for having a module called receiving a supply. So when you are looking out into the drawbacks of this particular diagram, we will just learn about, we will understand the diagram in the second class, the next class. Right now, today, in this class, we'll just go for understanding about the drawback of the particular activity diagram. It tells you what is happening, but not who does what. Okay, as the name itself implies that it is meant for activity, not for telling you like who are all the people involved into the process, what is the kind of role that they are going to play, are they a legitimate user or not, are they the right use cases or not. We are not going to, this diagram is not meant for that particular purpose. For that, we have the use case diagrams. In domain modeling, this diagram type does not convey which people or departments are responsible for each model, each activity. So domain modeling in the sense like we may have the system which are emerging from different disciplines. So the disciplines are domain specific. Okay, so in this domain modeling, the diagram type does not convey that which people or department are responsible for each activity. Okay, obviously, whatever the drawback that the first activity has got, same thing only. We are thinking in terms of the domain level. And in programming, it does not convey which class is responsible for each activity. So as we know, like this activity diagram is mainly meant for object-oriented programming. So in terms of a class form of representation, we don't have this particular information of like which class is responsible for executing or making this activity to happen. Okay, so class in the sense like there should be a kind of representation, correct? When you're going for creating object-oriented programming, one of the beauty of object-oriented programming is each and every activity can be labeled. Okay, it is because this particular activity only, because of this particular class only, this activity is happening, and this activity is happening in favor of this object by means of this functionality using this data. Okay, so while we are just going for representing this activity diagram, we will not have any kind of clarity over which particular class is responsible for this particular for this activity to happen. Okay, so that identity is missing out over here. So this is just a drawback, or we cannot tell it as a drawback as such. this is the characteristics of an activity diagram. Okay, so when this characteristics is a predominant factor over there, we cannot expect that particular activity diagram to address this two set of disadvantages what has been stated over here. Okay, so that is in a brief, we can learn about this activity diagram, and remaining we shall see in the next class. Thank you.